So on the last couple of slides, we were talking about the qualities that the attributes of a variable need to have in order for it to be useful in statistical analysis. On the next couple of slides, we're going to talk about a way of categorizing different variables based on what their attributes are like. And for better or worse, these levels of measurement that we're going to talk about are going to come up for a while in class because they often tell you which kinds of statistical analyses you can use. And as with before, I'm going to quickly go through some definitions and then provide examples on the next couple of slides. So variables that are at a nominal level of measurement have attributes that cannot be put in order. Variables at an ordinal level of measurement have attributes that can be put in order, but there's no set amount of distance between those attributes. Interval level variables have attributes that can be put in order and have the same amount of distance between each attribute, but they have no true 0 point. And ratio level variables have attributes that can be put in order, a set distance between all the attributes, and a true 0 point. That probably sounds like a whole lot of gobbledygook once again, so we're going to go through examples. First up, nominal variables. As I said on the last slide, nominal variables are characterized by having attributes that can't be put in order. So what does this mean exactly? Well, of all the possible values that the variable could take on, you can't say which one is the least or which one is the most. And examples of nominal variables include race. So you couldn't say that somebody who's black has more race or less race than somebody who's Asian or somebody who's white. They're just different categories that you can be in. Gender. You wouldn't say that somebody who's male has more or less gender than somebody who's female. They're just different categories that you can be in. Profession. You wouldn't say that somebody who's an architect has more or less of a profession than somebody who's an astronomer. They're just different professions that you can be in. And finally, type of fruit. You wouldn't say that an orange or an apple is more fruit than the other one. They're just different types of fruit. And so a good way to tell if you're looking at a nominal variable is to try to put the categories for that variable in order. And so answer this question for yourself for a moment. Which of the following fruits is the most fruit? Our variable is type of fruit, and our options are apple and orange. It doesn't make any sense, right? You wouldn't say that an apple is more fruit than an orange. They're just different kinds of fruit. And that's because type of fruit is a nominal level variable. So the answer to that is none. They're just types of fruits, and type of fruit is a nominal level variable. Next up, ordinal level variables. As I mentioned before, an ordinal level variable has attributes that can be put in order or ranked, but no set distance between those attributes. And as I'll describe in a moment, a good way to tell if you're looking at an ordinal variable is to ask yourself whether you could do basic arithmetic with those attributes or the variable categories. So some examples, first of all, police department rank. You'd say that a line officer is of a lower rank than a supervisor who's of a lower rank than the police chief. So line officer, supervisor, police chief are all different attributes that can be put in order from the least amount of rank to the most amount of rank. But you wouldn't say that there's the same distance between each of them. So somebody who's a line officer versus somebody who's their direct supervisor versus the police chief. There's a lot more distance between police chief and supervisor than there is between supervisor and line officer. Same thing, let's say small, medium, and large. You work at an ice cream shop and you have 3 different sizes for your ice cream cups. One's a small, one's a medium, and one's a large. It's possible that your small and medium are closer in size than your large, which could be a lot larger. So you'd have categories that can be put in order, but there isn't necessarily the same distance between those different categories or attributes. Another area where you see ordinal variables a lot are in Likert scale questions. And so a Likert scale question is anything where somebody asks you, how much do you agree or disagree with this? Strongly agree, somewhat agree, neither disagree nor agree, somewhat disagree, strongly disagree. And you can definitely put those in order from the least amount of agreement to the most amount of agreement, but it's hard to say that somebody's strongly disagree and somewhat disagree are the same distance away from each other as somewhat disagree and, say, neither agree nor disagree. So I'm going to also walk through an example that tells you how you can identify one of these ordinal variables. First, we're going to start out with something where we can put the statements in order. So I'm going to give you 3 statements that describe different levels of happiness. How happy are you? I'm very happy. I'm somewhat happy. Everything sucks. Throw me into a volcano. We can definitely put these different statements in order from least happy to most happy. Right? Pretty clear. But what you can see in looking at this is that there isn't necessarily the same amount of distance in between these different statements in terms of how much happiness they're describing. I'm very happy and I'm somewhat happy are probably closer together than I'm somewhat happy and throw me into a volcano. And so that's probably pretty obvious looking at it, but if it wasn't, there's a really easy test that you can do for whether or not something's an ordinal variable. And that test is to try to do basic arithmetic with those variables. And if you can't see this, you can just drag my head around the PowerPoint, I think, and look at what's underneath it. But what that says is I'm somewhat happy plus I'm very happy. And can you do that equation? I'm somewhat happy plus I'm very happy. The answer is no, of course you can't. You can't add 2 statements together that aren't numbers, so you would know that this is an ordinal variable. So I'm somewhat happy plus I'm very happy doesn't make any sense, and so this variable has failed your test for having a set distance between the categories. And you know it's ordinal. All right, so the next level of measurement is what we call interval. And interval level variables have attributes that can be put in order and that have a set distance between them, but have no true 0 point. So let's look at what that means. These are generally variables that are numerical, but where a score of 0 doesn't mean that there's none of that variable. And let's break that down with some examples. First, think about temperature in degrees. Can we put temperature in degrees in order? Absolutely. We would say that 80 degrees is hotter than 70 degrees, which is hotter than 50 degrees. There's also a set distance between them. Each increase in degree of temperature is the same distance away from the degree of temperature before it. So from 1 degree to 2 degrees is the same distance as from 3 degrees to 4 degrees, and so on. And we can test this really quickly using that arithmetic test. Can you add 2 temperatures together? What's 30 degrees plus 30 degrees? It's 60 degrees. So we've passed that test and we know for sure that there's a set distance between each of these different attributes that a temperature can take on in degrees. But let's look at that last one. There's no true 0 point. What this means is that when you have a temperature of 0, it doesn't mean that you have no temperature. 0 instead refers to some amount of temperature. And we'll go through one more example here with grades. So let's think about whether test scores can be put in order. Our variable is test scores, and let's say that some of the scores that people got were 0%, 70%, and 100% on this test that we're talking about. So note that this wouldn't be the full range of attributes you could have. It could be anywhere from 0 to 100%, but these are just a couple of examples to see whether we can put them in order. And here the answers are pretty clear yes, right? We would say that 70% is more than 0% and 100% is more than 70%. So we passed the test for whether we can put these attributes in order. Is there a set distance between them? Well, let's do some basic arithmetic. What's 100% minus 70%? 30%. And as a math problem, that's possible to do. So we've passed that test for whether this variable of test scores has the same distance between all of its attributes. Another way to think about it again is that the distance from 90% to 91% is the same as the distance from 92% to 93%. Each increase in a percentage is the same amount as the last one. But do we have a true 0 point? Well, what happens if you get a grade of 0 on a test? Does it mean that you got no grade? Unfortunately, no. You still have a test score. It's a 0. So in this case, 0 refers to something, and it doesn't refer to having none of the variable. It's just a different value that the variable can take on. So again, with interval variables, they're usually numerical, meaning they're made of numbers. The attributes can be put in order. There's a set distance between them, but When you have a value of 0, it's just some value that the variable can take on. It doesn't mean that you have none of that thing. This all brings us to, last but not least, ratio level measurement. And you can probably tell where this is going. Ratio level variables have attributes that can be put in order, have a set distance between them, and have a true 0 point. In other words, ratio variables are generally numerical, so made of numbers, and have values where a score of 0 means there is none of the thing that the variable is measuring. Examples of ratio variables include the number of murders. We can definitely put number of murders in order. 5 murders is more than 2 murders, which is more than no murders. There's a set distance between them. The distance from 1 murder to 2 murders is the same as the distance from 3 murder to 4 murders, and so on. And we can also do that test, right? So is there a set distance between them? Well, can we do basic arithmetic? What's 3 murders plus 4 murders? 7 murders. Bam, we have a set distance between them. We also have a true 0 point. If you have 0 murders, that means you've had no murders today. As opposed to temperature, where again 0 didn't mean that there was no temperature, or grades where 0 didn't mean that there was no grade. Here, a 0 unequivocally means there are no murders. Another example of a ratio variable would be weight in pounds. It's numerical, meaning that you can put the different numbers in order, there's a set distance between them, and looking at that 0 point, if something weighs 0 pounds, you would say that it weighs nothing at all. So 0 means there is no weight. Another one of these is distance in miles. So you can put the different attributes in order. There's a set distance between them because it's numerical. And there is a true 0 point. So a distance of 0 means that there is no distance. And finally, I'll go through this with one more example, which is number of cats that you own, just to really bring us full circle here. So our variable is number of cats. And a couple of possible attributes that this variable could take on would be 0 cats, 1 cat, or 10 cats. And we can absolutely say that these different attributes can be put in order. And again, these are not all the possible attributes that the variable could take on. This is just a selection of them to see whether we could put them in order. And the answer here is yes. 1 cat is more than 0 cats, 10 cats is more than 1 cat. Is there a set distance between these attributes? Yes, and we know that because we can do this arithmetic test. What's 1 cat plus 2 cats? Easy, that's 3 cats. We have a set distance between these attributes. We also have a 0 point, and we can answer that question by looking at this question. If you have 0 cats, do you have no cats? And the answer is yes. 0 cats means that there is none of the thing the variable is measuring, which is number of cats. So we have attributes that can be put in order, a set distance between them, and a true 0 point. In other words, we have a ratio variable. So just as a recap, because this is a lot, I put together this table that shows you which of these different characteristics each level of measurement has. And I suggest that you refer to this in the next weeks that we have, because these levels of measurement will keep coming back and coming back and coming back. Well, this officially concludes our lecture for today, so I'm going to leave you with a reminder that the first problem set is due at the end of the week. That means Sunday, September 13th, at the end of the day on Blackboard. The problem set itself consists of multiple choice and short answer questions, and all of them will be related to topics in this lecture. As a reminder, you can also find additional resources on Blackboard in the Week 2 folder. And the problem set itself is worth 20 points out of the total 250 in the class. Also as a reminder, we will soon be having the optional review and Q&A session. At the time I'm recording this lecture, I don't have the survey in yet, but I will be announcing the time slot on Monday after the survey results are all in from the class survey. The session will also be recorded, so if you're unable to make the slot the Q&A session happens at, you can still watch and see other people's questions and answers. I'm also just generally available at my office hours, which are from 12 to 2 on Fridays, or by appointment. You can also email me questions if you have them. I'm happy to answer them that way as well. So that's all I have for you guys. Good luck, and I will be doing this again next week.